Hello everybody and welcome to today's webinar, and I'm joined today by Rikard Edgren, and he will be presenting trying to teach testing skills and judgment. So we're delighted that Rikard would join us, and as you can see in the photo there, Rikard was the winner of the Best Tutorial Award at the EuroSTAR conference last year, and he's also been part of the committee team in 2012, I believe, in Amsterdam. So thank you very much, Rikard, for taking time out today to be part of this Best of EuroSTAR series. If you'd like to ask Rikard any questions, we have a discussion set up over on Test Huddle, and I'm just going to share with you a link to this discussion. So if you see in your chat box there, and let me just hit send, you will have a link there that will bring you right into the discussion, and that's where we'll be heading directly after the webinar. But feel free to type your questions at any point, and we'll address them as soon as we're finished here. So now, without further ado, let me hand you over to today's presenter, Rikard. Hello, Rikard.
Hi there. Thanks for the introduction. So, I'm very happy that you attend my webinar. It feels a bit strange that I can't see you, but I hope you can hear me. And also hi to all of you who are looking at this afterwards. So the topic today is trying to teach testing skills and judgment. And it's about my experiences as a teacher in testing at higher vocational studies programs. And I will focus on how I tried to teach the students not the testing theory that they also have to learn, but more of the hard to grasp skills and judgment, like, for instance, when is it appropriate to do this kind of testing, and why is this bug more important than the other, and how should we report things and stuff like that. So it's more of these intangible and difficult stuff that I feel are very important in software testing. So now I clicked on my keyboard and I'm waiting for the next slide. Maybe I'm slow, or maybe the computers are slow. Anyway, I can start to tell you a bit about where I've taught this. So this is in Sweden. It's higher vocational studies programs. It's 1 year or 2 year full-time, and it's sponsored by Sweden State. So it's like a way to get more good people in work, and it's based on the market needs. So these educations come to place when a lot of organizations say we need more testers, and then they set up an education, and they have teachers, and together with Henrik Emilsson we have been teachers a lot in schools like this. And if it's a year or two, there are lots of different classes involving. It might be programming, it might be about databases, it might be about test tools and testing theory, and etc., etc. It's also often they have some supervised internship, so they go out to a company and are there for 3 or 4 months and get help to learn even more and get practical education. And after this, they are ready to work as testers. And most of them are, after going into this education with motivation, they are ready to do good work when they have completed the school. So I've been involved in this for several schools, and I have done more than 1,500 hours of testing. So I have at least some experience. That doesn't mean that what I'm telling you is the good way to do it. Rather, that's the way we did it, and we felt it was good and worth sharing. So the philosophy that me and Henrik had, and what I have written here is not something that we wrote down before we started, rather it's something I wrote down afterwards. It's an after construction that Henrik has agreed upon. That was how we were doing stuff. So we think that in order to teach someone something, they have to be motivated. That's really important. If they aren't motivated, they won't learn almost anything. And in order to keep them motivated, they have to have challenging, interesting tasks, interesting lessons, good test objects. It should be hands-on, it should be practical, they should feel they learn stuff. And we have to keep them motivated all the time. Or rather, they are motivated in themselves, but we have to help them stay motivated. I also can say that we didn't do this for the money. It was consultant work and we got paid, but it was not well paid. And in order to do proper teaching, you have to invest a lot of time preparing stuff, and you have to give them challenging exercises that you have to correct and read properly and give them a lot of feedback. So there were a lot of extra hours trying to set up the classes and doing a review of the work they do. So it was not for the money, it was rather for doing good stuff for testing in Sweden, and also for us to learn a lot about testing, because we learn when we try to teach it. We also were clear that the classes was not about us as teachers. It was not about us showing off how good we are, even that might have happened once or twice. It is about the students. It's about what they need and how they can become better testers. So we have to be very adept and to look at how they perceive what we do, so we feel that they move forward. We'll also try to encourage new ideas so they start thinking for themselves. Because even if we set up really interesting exercises in class, when they face reality, it will be something completely different. And they have to be able to come up with new ideas how to tackle those problems in that unique situation. So we have a lot of discussion, open discussions with the students where they could ask questions and add their own ideas and stuff like that. It's important to think for yourself. And one last thing in how we taught also was that we were very clear that we were not afraid that things would go wrong, which was a key for us in order to set up very open exercises, meaning exercises where we as teachers did not have the solutions. Exercises where we didn't really know what would happen and what they would find, but rather we trusted that it would be interesting and that we could help them learn stuff while doing this. So it could be taking an open source software that neither we or the students have used before and see what it has and what we can find when we test it. And as it turned out, it showed that any kind of software you take and you studied it properly, you will see interesting stuff there. Sometimes things we saw, sometimes things the students saw. So if you are a teacher, you don't have to be certain that you know the exact right answer, because there will be interesting things you find that you can talk about. So that was the basics of our philosophy and how we entered this teaching experience. So the focus of my talk here is not about different kinds of testing theory and how to learn those. We have taught that as well. That's important. But it's rather all these tacit skills and judgments that we must have as testers. For instance, that we are able to ask good questions. That's not something that you can't teach 5 questions and say, as long as you can ask these questions, everything will be fine. Because in a new situation, there will be other questions that are the important ones to ask. And not only to ask good questions, also to be able to act on the answers you receive and what they mean for your testing. And be able to ask follow-up questions. So one example for this would be that quite often when we hand them an exercise, we say, oh, does anyone have any questions? And we know there are several important questions that they should ask. But as a student, you just listen to the teacher and you're quiet, and then we have to repeat them. Are you really sure you don't have any questions? Or maybe in the beginning we have to help them with questions. Doesn't anyone want to ask what the purpose of this software really is and what quality means to you and stuff like that? So we try to force them to ask questions so they can practice doing it. We also have the skill of critical thinking that I will go in more depth later on. And the next one is understanding what is important, which I think is the very most important skill in testing. Because we all know we can't test everything. But if we understand what is really important, then we have a better chance of doing valuable testing. But the difficult thing is that there are so many things that are important. So it's not an easy task to understand what's important. And it's not something you can learn in an hour. It's not something you can ask someone, what's important, and then you get the answer that solves all your problems. It's something you learn over time. And you do it in a variety of ways. And that's something we wanted to teach our students. And a key to that would be to give them a really difficult exercise. Like, for instance, pick an open source software, contact the development team, and ask them what they want help with testing. Based on what information they send to you, design a test strategy that will find important problems. Now that's difficult. It requires a lot of different kinds of skill, including to understand what is important. Also in these exercises, there is an importance of the rapid learning, because that's also something we need to do as testers. We need to learn a lot of stuff all the time, and if we do it fast, we can do better testing. So in our classes, we have a variety of software that they use, because we want them to see something new and be forced to learn how that software is used in order to be able to test it. And by doing learning, a lot of times you get better at it. We want them to learn to see many perspectives and have many test ideas. More test ideas than you can test, so you can disregard the ones that aren't important and focus on the ones you find most fruitful. We want them to be able to design a test strategy that will meet the needs of this specific project. We also want them to be able to capture serendipity when it occurs, because serendipity, in my experience, is very important, meaning that I test something in order to look for something special, but as I do that, I find something else that's really interesting and important. So when I count these kind of bugs I see, half of them are not the things I look for. It's just things I stumble upon. But I stumble upon them because I know a lot about the software, and I know a lot about which kind of failures there could be, and maybe I have set up my machine in certain ways, and maybe I'm using a very complex document, so it's a bigger chance of some serendipity over there. But it's something you can't really say to something, today you're going to learn to capture serendipity. This is how you do it. It's rather something that you have to do many times. You have to be aware that it might happen, and you have to be able to see the opportunities when they occur. We also want the testers to be able to realize when testing is good enough, because you can test something forever, but somewhere you have to stop, and you have to make the judgment. Should I stop here now and move on to the next area? Yes, because of, and understand that reasoning that happens. And these things are not something that we have a course for each of these. Rather, they are embedded in all the other kinds of courses we had. So one typical example of a course or a week we might have would be a section about think like a tester. So I will now show you some examples that I use when I teach this in these schools in a think like a tester week or course. And regardless of what kind of thing I want to teach them, I always want to start with a story. And the reason why I want to start with a story is that a story better explains why we are doing this and what kinds of good things can come out from it, why this is important to learn. So my story for thinking like a tester goes like this. I call it the Wilhelm story. And it's based on many years ago. I was in a situation where there was a colleague who worked in another department, and he was maybe he was going to be a tester. So he was assigned to me, and I would try to teach him and see where he needed some training and stuff like that. So at one moment he was doing some testing, and I was sitting next to him while he was doing the testing. And I was just sitting quietly because I wanted to see how he did it, how he thought, and what he saw and stuff like that. So what he tested, there was test cases that he could follow. So we followed the test cases and did the things that were said. And as he performed these different steps, I saw bugs coming up on the screen. One to the left and another one to the right, and the big one up in the top. But Wilhelm, he just moved on, kept on to the next step, and the next step, and another bug popped up. But he didn't seem to notice them. So I had to stop him. And I said, Wilhelm, stop now. Didn't you see what just happened over there? No, what do you mean? He said, wait, go back and I'll show you. So we went back and we did the same step again and the same bug occurred. And there, over there, don't you see? Isn't that a bug, right? No, said Wilhelm. Is it a bug? And I had to explain like, yeah, but if that's displayed over there, that might mean that the user thinks in that direction and they might take the wrong decision based on that. At least there is a risk about that. This is not good. We have fixed problems like this before. And Wilhelm said that, yeah, but you know, these kind of things are super difficult to really get right. No, I don't think we want to fix that one. And that was the moment when I realized that Wilhelm could not be a tester because he didn't want to see problems. He wanted things to work smoothly and look good and just do my test and be over with it. So it's important as a tester to want to see problems because otherwise we won't find the bugs that people pay us to find. So that was my Wilhelm story. And so I have a bunch of these stories based on my experience that I can tell to the students so we get a good start. And not only does it probably tell something useful, it's also a nice start of a new chapter, so to say. Now I'm not quiet to test your patience. I'm just quiet because I thought I would get a new slide. There it got. Maybe Dara helped me. Thank you. After I've told the story, I usually take a definition of this area we're teaching. So for thinking like a tester, what you see on the slide, that's my definition of thinking like a tester. And I won't read it out loud. But this is very elaborate, right? And the reason I sometimes write like this is because I want the students to have the slide material and that they can go back later on in time to look at it. I don't want it to be just one word over here, one word over there, because that will be a good presentation that is really capturing stuff like that, but it won't be something they can have much use for later on. So in my definitions, I try to explain the really basic things about this. And together with the definition, I also want to highlight the purpose of why we are teaching what we are teaching right now. So I explain to them that if they don't think like a tester, they will be like Wilhelm. They won't see any problems. I will explain to them, if you don't learn how to learn stuff fast, it will take too long time for you in order to be productive. I tell them that if you don't have any pragmatic thinking, you will have difficulties deciding that you've done enough testing. And I will also probably say that the most important thing in testing is to realize what is important and then try to test it. I might even say that testing in essence is quite easy, right? It's just find out what's important and then you test it. And then I follow up saying that, but unfortunately very many things are important. So there's a lot of thinking we need to do. So for critical thinking, I might have some slides saying stuff like this. Now we need to go back. I will say this statement. I will say, question everything, especially this statement. And I want the students to be a bit, well, what's that? Strange. Especially, so I should question everything, but I should also question everything. What does that mean? And then we might have a discussion about it. And we might talk about, someone might say, yeah, but if we question everything, we will be obnoxious people that no one wants to work with, right? So we can't question everything. Okay, so what should we question? well, we should question what's important and things that are maybe dubious, or maybe we should question the things that everybody believes are givens that can't be changed. So we bring new perspectives to stuff like this. Maybe we should have a small questioning in the back of our head all the time, but maybe we don't say everything out loud and stuff like that. So I would like some discussion in the class so they think for themselves and maybe they make up their own mind what it means for them. I would talk about what if. What if would be the tester's #1 words, because we think about something to test and then we say, well, what if a user afterwards does this thing? Or what if we don't have that thing that this thing depends upon? What if we combine this feature with the other feature we did half a year ago? And then vice versa and stuff like that. The what if is our starting point for getting new ideas about how things can go wrong and what kinds of things we want to test. I will talk about different kind of biases and that we can't avoid them but manage them, as is said in Lessons Learned in Software Testing, lesson number 39. I might give an example of the bias called spectacular fallacy, which is something testers often stumble upon. I do it myself. It's when we see a bug and then we think that, wow, that must be because I upgraded Chrome this morning. It must be that. They introduced a bug over there. Wow. They have messed up again, I might think. And have a spectacular fallacy thinking that that one explained this thing and over there. And quite often when you have a theory like that, in my experience, it's very much simpler problems. It might be that I made a configuration mistake or that the function never worked at all and stuff like that. So understanding different kind of biases is very useful because then we understand how we think, and when we understand how we think, we can manage that and test in better ways. I would also give examples of the area I teach. So for critical thinking, I would give examples regarding how to evaluate concepts, how I as a tester can apply critical thinking early on the whiteboard. Maybe when they design a new feature, maybe I investigate what a competitor does and realize that they do it in a much better way, and that maybe we should try to learn from that without copying and infringing their patents or something like that. I will give examples of how I question the product, how maybe you can say that each test I do is a question to the product, where I have my critical thinking. How will you handle if I put this into you? And what do you say if I do this? I question the product's abilities because I want to challenge the product and see how we can handle many different situations, so we can fix any bugs that are there. I also give the example that tester can make mistakes, which is actually true. Also, testers can make mistakes. And one thing that happens to me sometimes is that I see very many problems in a product. And I feel that, well, this is too many problems. It can't be that bad. Maybe I'm doing something wrong. Maybe I have misinterpreted what this software is about. Maybe I have installed it properly, or maybe I'm using data that shouldn't be supported and we only had one bug that it was imported in the beginning, etc., etc. So I need to be critical also about my own thinking. And I can say that the critical thinking is embedded in who we are as testers. It's a core central thing about who we are. We are not afraid to be critical. The other people, maybe they would just want to finish their programming and are happy when it works. But we have the courage to think critical and find problems that make it slower to complete this iteration, but will lead to a better situation in the end. Whenever I show a slide like this, I almost always also ask in the end, so any comments or questions on that? But it's very difficult for you to have that since you're muted from this webinar. So Now I'm going to show you a small little thinking exercise that I use in this class. And this one I have grabbed from the internet, so you have the source in the bottom of the slide, so you can have a look at it yourself. So this is a thinking exercise, and we have a situation here where we have one completely empty house. And we have one person entering the house, and no one else is walking into the house, and a bit later on, 2 persons come out. And this is strange, because it was one person entering, it was empty, no one else went in, and 2 persons come out. So if you would talk about this with a biologist, they would say that, well, it was a pregnant person, and she came out with a baby. And a mathematician, he would say that, interesting. So now the house has -1 people, and if 1 more person enters, it will be empty. Cool. So the question to you, fellow webinar attendees, how would a tester think in this situation? And now I would, in a real situation, give you a minute or 2 or 3 to think about this. I won't do that now, but if you are looking at the webinar afterwards, you can stop here, try to find a solution for yourself, and then we will have the debrief in a short moment's time. So when I debrief an exercise, I want to emphasize things that I feel are important about this and things that are important as a tester. So one part of this critical thinking is that we question the instructions given, the specification, right? We question that, was the house really empty? Can we examine the house beforehand to have a real close look at it? We question, didn't anyone else enter? For instance, maybe there is a tunnel going into the house. Maybe we question what the results were and say that you haven't given anything. You say 2 persons. What does that mean? Is it 2 identical persons, or is it 1 person and that person's father, or is it 2 different persons than the ones who entered? Stuff like that. We use the critical thinking to question different parts of what we are studying. As a tester, I almost always want to reproduce stuff, right? I want to see, does this happen again? I want to send in 1 person again and see if we get 2 people out. I also want to reproduce with variations. So does it happen only for 1 person or for any person? Does it happen for a dog? Does it happen if I put a microwave oven in it? What if I send in 2 persons? Will I get 3 persons out, or maybe 4? I also want to look for side effects in this. Does anything else happen during this time? Maybe this is an identical clone that comes out. Maybe I need to study the persons that go out and ask them questions. What did it feel like in the house? What happened really? And stuff like that. I want to look at more stuff than just the bare things we learned about in the beginning. I also want to know about the purpose. What's the house supposed to do? Maybe this is how it's intended to do. And without knowing, can I really say that something's wrong? Probably not. But I might have very interesting observations that I can share that might be useful for the house owner or the house creator. So that was an exercise. And here is my model of the education that we do. So there's some work that are teacher work and some work that are the student work. And as all models, this is of course a simplification. It's not as easy as this. But as a teacher, I tell stories that I just did, and I explain the purpose of what we are doing. I then move on to explain theory. And I invite the students to ask questions about that. Because what I think is important might not cover what they feel is important. And what I think I explain thoroughly might not be at all good for them. So I need the questions from them in order to improve my teaching. I also would share my tips and tricks for an area. Maybe if I teach specification-based testing, I might say that if you're reviewing a specification and you know that all the other peoples are reading the specification starting from the top, then it might be a trick to start from the bottom, just to have a look at it in another way. Different kind of experiences I have. I may show them different examples, and preferably it will be examples from real life that I have and I'm allowed to share. Or it could be examples that we do together. So we will do testing together in class to have shared experiences that we can talk about. The students have a lot of work to do with themselves. They have to read stuff. They have to discuss stuff. And I want to emphasize that students in this kind of setup in Sweden, in higher vocational studies, it has been very fruitful with small group exercises, 3 or 4 people, and where they discuss a lot among themselves. Because when they discuss things, they have to dig deeper in their own understanding when they have to explain to someone else. And they will get new ideas from their friends, and they will challenge each other, and they will learn more. So groups with a lot of discussions will get a lot better than groups that don't have any discussions. They will also do a lot of exercises. Some exercises we will do in class and some they will do at home. They will also have almost always a weekly assignment. So there is one weekly hand-in that they have to do in order to pass the course. And the reason why we do this is because they tend to do more work if they have to. I mean, humans are a bit lazy and we might skip things we don't have to do. But if they have one challenging weekly assignment that they have to do, they will have to learn by doing that. And that assignment will also be something to grade against. But it's not only for examination, it's also a learning opportunity by doing that assignment. Another thing that I feel is very important is to have authentic problems, where the house I just explained is very much not an authentic problem. That's a hypothetical situation. Those are useful as well, but even more useful are the big, complex exercises and challenges they have when they are given a real software to interact with and think about. They are given more time to work on it and really think about how are we going to test this, and then actually test it and figure out more about it and actually report about their findings. So for some authentic problems, me and Henrik, we set up a big mind map that we had where we had faked the situation. So we had a lot of stakeholders and names and what they were interested in, and we had the developers and what they felt they were doing and stuff like that. So a lot of extra information, but we didn't share that information. The students had to ask questions to get that information, so they would practice asking questions and acting on the answers. So authentic problems are more challenging and more rewarding. But I also think that if you start with authentic problems, it will be too difficult because these are newcomers to the field. They have to start with smaller and simpler exercises to have those experiences, and then they can tackle more authentic and more difficult problems. And my biggest box here is the feedback box. And that's what I think is very important, that the students get feedback on the work they do. And when I give feedback, I spend a lot of time giving feedback because I think this is the most important part of everything. Because then you can be individual, because each person has some difficulties that other person don't have. Some testers, new testers, are really good at some stuff but weaker at other stuff, and it's very individual. And as a teacher, it is easier than I thought to see what they need help with. So when I give feedback, my style can vary a lot depending on the situation. I might be very encouraging because I feel I need to push them. I want to give them some more self-confidence because that's the way they will get better. In other situations, I might be more critical and maybe even questioning the work they did. Why did you do it like that? And they have to explain it. And when they explain it, they have to think more about what they do and how they think and how they do it. Sometimes I might be a bit more enlightening in my style and saying that, have you thought about this thing and maybe about that thing, and giving them new ideas on how to move on forward. So my feedback style will be different depending on the situation. But I feel it's a very important part of the classes we have taught. Probably the most important part. So I'm going to say a few words about the courseware, so like the material that we have for our classes. We built up a lot of our own material based on our experiences, and almost all exercises are created by ourselves, just a few borrowed. We borrow some material from the BBST classes, which are free and open and you can use, and a few things also from the rapid testing by James Bach and Michael Bolton. We do a lot of work with James Bach's heuristic test strategy model, and the reason for that is that it is very good, and it's also a challenging material to work with because it gives you a structure of how to think about things, but it doesn't give you the answers. You have to do the work yourself to find the answers. So each page in James Bach's HCSM can be used to look at the product and get new ideas, but you have to do all the work by yourselves. And that's a good thing. That's what we want the students to do. We want them to work with things and have to use their own minds and not be fed with stuff. Because we know that even if they are fed with really good user stories to test, there will be a lot of other things they have to test, and there will be a lot of other thinking they need to do and a lot of conversations that they need to have in order to test it properly. Book-wise, we have used Lessons Learned in Software Testing, which is the best book about software testing according to me. We have used Torbjörn Ryber's Essential Test Design, which is quite similar to Lee Copeland's test design book, but Torbjörn's is also in Swedish, and since our classes are in Swedish, that's a better one. When we talk about requirements, we use Gausser-Weinberg's Exploring Requirements, and that's not a good book only for requirements. It's good for testers as well, because it has a lot of good stuff about how to understand the users and how to understand the software and its limitations and stuff like that. So that's another of my favorite testing books, even though it's not about testing. And also later on we have included Explore It by Elisabeth Henriksson, which is a very good book about exploratory testing. And we also add some miscellaneous articles that they can acquire from the web that we find worthwhile. We also often have compulsory literature. This is something you have to read, and then we have some recommended literature, so that there is material to go even further for the ones that are even more motivated. The classes are designed so that each student can do 40 hours of work every week if they have the opportunity, and improve all the time. When we started these courses, I thought that creating the material and creating the exercises was the most important thing to do. But the last year I've changed my mind. Now I think it's the individual feedback that I can give on the work that I've done that are most important. Because that's when their thinking is, they get feedback on their actual thinking and they can progress. It's individual in a way that the book never is. Of course you need material and exercise and stuff like that, but emphasis now is on the feedback, for me at least. I also explained examples that are very useful, and I try to design my classes so I have theory and abstract stuff, but it's combined with actual concrete examples, so you have something tangible as well. And if you have the abstract stuff and the tangible stuff, and you can get your own mix and find your own stuff in there. And the very best examples are probably the ones that we create together in class. When we test something, or I test it and they help me test it. Or maybe we test it all and talk about our experiences. And I also use authentic examples that I talk a lot about. So I can show them a test report I made, and I explain what I thought about when I created it, and how the ones that read it, what they thought about it, and why it was structured the way it was. These things are in Swedish because I work in Sweden and almost always write in Swedish. But a few examples I have created also in English, and they are available in public for you if you want to have a look at it. So I have created an exploratory testing sample. It's a 21-minute YouTube video, which is a session that I also have done live in class, but now I did it because I want to share with more people an example of exploratory testing. I have a test strategy that I created in the test lab at last EuroSTAR, where it might not be so important the exact things in it rather than what kind of things that are there. So you see an example of how a test strategy can look like and how it felt worthwhile to do it in this unique situation, because in your situation it might be totally different what's important. I have a test analysis of a super small software called Screenplug, where I look at it carefully and discuss what I want to test, and also try to explain how I come to the conclusion that I want to test this stuff. And I also have a test execution example of a scenario test and the results from that scenario test, where I test LibreOffice. And I would really love to see more public examples. We have extremely few public examples that are useful. And there are many reasons for this, but one reason is that in many cases you are not allowed to share your actual testing and your actual test results. Your company won't allow you to do it. And another one is that even if you would share it, it wouldn't make any sense to someone who doesn't understand the actual software. So for the examples that I have made public here, there was a lot of work in order to prepare it and to make it explainable and to do it in a way so it might be readable. I think these examples are useful, but maybe they aren't for others. But there's a lot of work involved in doing public examples. But I really hope that one or two of you who are listening to this will share more actual examples of your testing and your test strategies and your test reports and stuff like that. So we have more things to look at to get inspired from. Now I'm waiting for the next slide. Maybe it will come later on. I also understand if you don't create any examples and make them public, because all of us, we are occupied with what we're doing, right? We have a lot of stuff to do at work, and we don't have that much time. So if you do it, maybe you have to do it on your spare time, and you have even better things to do in your spare time than to create testing examples for the rest of the testing world. So I'm going to try to sum up this, and I must say that this has been a really challenge for me as a teacher and also an opportunity, and I have learned tons being a teacher, because when you have to explain something, then you really need to learn it once again for yourself. And when I have to explain it in different ways to different persons because they are different, I learn even more about it. And when I do this teaching and talk about testing, I become very good at talking about testing. And this is extremely useful in my normal work as a test consultant, because when I talk to different kinds of stakeholders, I can talk about testing in many different ways because I have a lot of words to talk about it. And when I can explain what to do, they can explain better what they want to see from testing, etc., etc. So testing, the actual test execution might be the core of testing, but how we talk about it, it's equally important, because we have to discuss our results, we have to discuss what we're going to test and stuff like that. And that's needed in order to do valuable testing that means something. The test results aren't worth anything if they aren't communicated properly. I also have a quote here from a student that I liked. The quote says, "If a student wants a crystal clear education with easy assignments, you will probably not like it," says Magnus. And I was happy to see this, because that was something I wanted it to be like. Me and Henrik, we wanted it to be challenging assignments where they have to think for yourself. It's not you go to school and someone pours knowledge inside your head. You have to do the work for yourself. And this quote shows that at least to some that was the case as well. And I also can say that I can't really say that I can teach them to do these things with skill and judgment, but I can say that I know how to help students acquire it, that I know how I can set up exercises so they are challenged, and I know how to give feedback so they can move on and get better at it. And if I can do it, you can do it too. And one way to start this might be to read a paper about this that I've written, which is like maybe too long. It's like 30 pages, and that I intend to win the best paper award at EuroSTAR, but Declan beat me to it with an even better paper. But in this paper I describe more details about what I talked about today. Some examples are given and other stuff, and it will be released by EuroSTAR in March 2015, so that's just a month from now. And maybe that will inspire you in some way, I hope. That's the purpose of writing the paper, giving the presentation, and giving this webinar. My purpose is that more people will be inspired to do better teaching, and we will get more and better testers, I hope. Because you always have to be critical, right? So you have to be critical of what I say. I might be very wrong here. This might have worked decent in Sweden in this situation. There might be totally different thing that will work for you, but that's something that you will have to figure out for yourself. And I have also put up my email address in case you want to ask me some personal questions. Otherwise, we will have the test huddle where you can ask questions and I will try to answer them. And that was my talk. And I say thank you to Darrow and EuroSTAR for letting me have this webinar.
And thank you very much, Rikard, for that webinar, as well as all of the attendees who took time out today to come along. As Rikard mentioned there as well, we will have his ebook available for download over on Test Huddle on the 18th of next month. So looking forward to reading that. And before we head across to Test Huddle, let me just tell you about tomorrow's webinar. It's the last webinar we have as part of this Best of EuroSTAR series. And this webinar is with René Trudeau, and he will be doing a fun webinar entitled Passionate Dating for Testers. So it's a quite interesting title, I believe. I'm looking forward to seeing that one. And last but not least, let me just share with you again the link to Rikard's discussion over on Test Huddle, where all the Q&A will be taking place. And if you look into your chat box there, you'll see the link once again. And just follow that link, or alternatively, just look up testhuddle.com and you'll see the discussion there. Thanks again, Rikard. The webinar is now over, and I'll see you all over on Test Huddle.